My name is Harmony. I was created by robotics.
USA just released fully functioning female robots, May News. USA has forever remained at the forefront of all technological advancements and innovation that we witness all around us. In today's video, we bring you a monthly roundup of all news robotics from the American sphere to bring you up to date with just how much America is doing to get ahead in the robot and AI race. Therefore, let's get right into it. Joystick-controlled robotic surgeon. Endovascular operations for treating stroke or aneurysms require specialized training in which it takes years to become proficient. Consequently, only a small portion of doctors are able to complete them, and they tend to be located at large medical centers in urban areas. When a patient is experiencing a stroke or aneurysm, there is a golden hour during which they can be treated without lasting consequences. That's all fine and good if you happen to be located within a few minutes of a major medical center, but for patients in outlying areas without access to specially trained surgeons, that could mean the difference between recovering or not. With that in mind, engineers at MIT have developed a telerobotic surgical system using a modified joystick that surgeons can use to perform operations remotely. According to a paper published in the journal Science Robotics, the system uses a flexible magnetized guide wire to navigate through blood vessels and reach the location of a clot to retrieve it or break it up. If these systems were set up at hospitals around the country and the world, they could be operated remotely by trained surgeons in other cities, reducing the response time as well as rates of fatality and long-term disability.
其实5G 呢，就是让我们可以做到在很多场合，比如说救灾的场合，还有一些像边防上，一个人可以去做几千公里，或者是那个几百公里，各种各样的这样点对点的一些连接。
Human cells now power ROBOFISH. An artificial fish built from human heart cells could teach us how the organ functions. The human heart can pump without signals from the brain, a feature known as automaticity. This is coordinated using electrical signals and mechanical feedback within the heart cell tissue, but the process isn't fully understood. Kit Parker at Harvard University and his colleagues built a biohybrid fish using plastic, gelatin, and a two-sided fin of human cardiac cells in order to better understand these automatic physical processes. The work follows previous projects at Parker's lab that built stingray and jellyfish-like biohybrids from heart cells. When people are trying to build human hearts for regenerative medicine, they only try to replicate the anatomy. But there are some biophysical principles that are very important in the heart, says Parker. By understanding the laws that regulate muscular pumps, we might be able to better treat heart disease, he says. When the fish was placed in a cell culture, one side of its tail contracted, and then the other did, producing movement similar to that of species such as zebrafish that use their tail fin to swim. The biohybrid fish swam for 108 days, or 38 million beats, and had a greater swimming speed than a wild fish of a similar size. Aside from its mirroring of nature, the fish's movement has also shed light on functions of the heart. Scientists have long thought that when the human heart relaxes between beats, blood fills the ventricles passively, but the fish's fin contractions suggest it might be a more active process, says Parker. He and his colleagues also designed a type of pacemaker, the G node, to function like the timekeeping sinoatrial node in the human heart and spark the fin to regularly contract. It brings home how much of a cardiac regulation happens autonomously at the level of the actual contractile structures, says Gotel. Parker says his team will now look at how the work can be used to build artificial hearts. We've taken away what we needed to learn, and we're applying it to the study of pediatric heart disease and regenerative medicine, and we're moving on to the next biohybrid. U.S. military employ armed dog-like robot. The U.S. military may be getting a dog-like quadruped robot armed with a sniper rifle. The robot, developed by Ghost Robotics of Philadelphia, is a new version of its Vision series of legged robots. The U.S. Air Force is currently testing an unarmed version of these robots for use as perimeter security at the Tyndall Air Force Base in Florida. Ghost Robotics displayed the armed version at the annual meeting of the Association of the United States Army held in Washington, D.C. The robot is fitted with a special-purpose unmanned rifle pod from Sword Defense with a powerful 6.5mm sniper rifle. This has day and night cameras and an effective range of 1,200 meters. Ghost Robotics has been developing quadruped robots since 2015 and has previously displayed versions fitted with additions including arms for bomb disposal and a disruptor. a shotgun-like device for disabling bombs. The robots are highly mobile, able to cross rugged terrain that might be difficult for wheeled and tracked machines, and can operate with a high degree of autonomy. For example, the perimeter patrol robots are able to follow a preset route, deviating where necessary to avoid obstacles, and alerting a human operator when they encounter something unexpected, such as a possible intruder. Robotic gripper with a sense of touch. As interactions between humans and robots become more common, it will become increasingly important that robots have a better sense of the environment around them. The last thing we want is a robot harming someone or breaking something because they don't know their own strength. Scientists and engineers from MIT developed a new robotic system that uses fin ray grippers imbued with a sense of touch. As explained in a paper uploaded to Arxiv, fin ray grippers, which are modeled after fish fins, are useful for their ability to conform to the surface of an object. Rather than bend away from a surface, they curl inward to wrap around it. Scientists achieved a sense of touch through an array of cameras embedded inside the grippers that watch for the way the fingers deform when in contact with a grasped object. By acutely measuring the way the gripper's shape changes, they can determine what it's holding in fine detail. In tests, they were able to determine the letters on the surface of a glass jar, as well as individual seeds on a plastic strawberry. Incorporating this level of feedback could improve the performance of robots in situations when they are interfacing with people, making them safer and more effective. Flying robot can now ride skateboard. Researchers at Caltech have built a bipedal robot that combines walking with flying to create a new type of locomotion, making it exceptionally nimble and capable of complex movements. Part walking robot, part flying drone, the newly developed Leonardo, short for Legs on Board drone, or LEO for short, can walk a slackline, hop, and even ride a skateboard. Developed by a team at Caltech's Center for Autonomous Systems and Technologies, LEO is the first robot that uses multi-joint legs and propeller-based thrusters to achieve a fine degree of control over its balance. A paper about the LEO robot was published online earlier and was featured on the cover of Science Robotics. We drew inspiration from nature. Think about the way birds are able to flap and hop to navigate telephone lines, says Sunjo Chung, corresponding author and Bren Professor of Aerospace and Control and Dynamical Systems. A complex yet intriguing behavior happens as birds move between walking and flying. We wanted to understand and learn from that. Bipedal robots are able to tackle complex real-world terrain by using the same sort of movements that humans use, like jumping or running or even climbing stairs, but they are stymied by rough terrain. Flying robots easily navigate tough terrain by simply avoiding the ground, but they face their own set of limitations: high energy consumption during flight and limited payload capacity. Robots with a multimodal locomotion ability are able to move through challenging environments more efficiently than traditional robots by appropriately switching between their available means of movement. In particular, LEO aims to bridge the gap between the two disparate domains of aerial and bipedal locomotion that are not typically intertwined in existing robotic systems, says Kyunam Kim, postdoctoral researcher at Caltech and co-lead author of the Science Robotics paper. AI that judges your face. Facial recognition software isn't new, but it is gaining new abilities. You likely have some version of it on your phone right now. We count on these programs to recognize us and grant access to our technology when we need it. We also count on them not to judge us for our appearance, even on our worst days. In the future, however, all of that could change because of a new advancement in facial recognition. Researchers taught an AI not only to recognize facial features, but to make snap judgments about a person's appearance. While being judged by a machine might hurt, it has important implications about the ways humans judge one another. According to a research paper published in the Proceedings of the National Academy of Sciences, the first impressions we form upon meeting a new person influence decisions we make about them, including decisions about hiring and sentencing. Researchers used machine learning to train an algorithm to make judgments based on photographs of faces which closely mirrored the judgments we make about ourselves and others. It's unclear what factors the algorithm used to make its judgments, but scientists think the data can still teach us how our appearance impacts the way we engage with the world. MIT's CHEETAH robot can now run. It seems this month has all been about robotic animals. First, there was Kawasaki's rideable goat-shaped robot unveiled at IREX in Tokyo, and now MIT's CSAIL has released a video showing its mini CHEETAH robot running faster than ever before. What's amazing/terrifying is that the cheetah taught itself how to run using a learn-by-experience method powered by artificial intelligence. Rather than programming how the robot should act in every situation, the robot learns to run in a simulator, using a simple neural network as the controller. Through trial and error, the robot can learn how to adapt to different surfaces and terrain that it encounters, much like how humans know to slow down on icy patches. Programming how a robot should act in every possible situation is simply very hard, explains MIT PhD student Gabriel Margolis and IAIFI postdoc Guy Yang in the recent MIT News press release. The process is tedious because if a robot were to fail on a particular terrain, a human engineer would need to identify the cause of failure and manually adapt the robot controller, and this process can require substantial human time. Learning by trial and error removes the need for a human to specify precisely how the robot should behave in every situation. This would work if 1. The robot can experience an extremely wide range of terrains, and 2. The robot can automatically improve its behavior with experience. Thanks to modern simulation tools, our robot can accumulate 100 days' worth of experience on diverse terrains in just 3 hours of actual time. We developed an approach by which the robot's behavior improves from simulated experience, and our approach critically also enables successful deployment of those learned behaviors in the real world. The intuition behind why the robot's running skills work well in the real world is, of all the environments it sees in this simulator, some will teach the robot skills that are useful in the real world. When operating in the real world, our controller identifies and executes the relevant skills in real time. Tesla's AI humanoid, Optimus. Tesla will branch out from building electric, self-driving cars to produce humanoid robots designed to eliminate dangerous, repetitive, boring tasks and respond to voice commands from their owners. The robot, referred to as Optimus by those inside the company, will be 173 centimeters tall and weigh 57 kilograms. Its body will be powered by 40 electromechanical actuators, and its face will feature a screen display. Optimus will be able to carry a cargo of up to 20 kilograms, and Tesla's CEO Elon Musk claims that a working prototype will be ready next year. Speaking at the company's AI Day event, designed to attract engineering and research talent to the company, Musk said that much of the technology in Tesla's self-driving cars is applicable to or useful in creating humanoid robots. Tesla is arguably the world's biggest robotics company because our cars are like semi-sentient robots on wheels, he said. It kind of makes sense to put that onto a humanoid form. We're also quite good at sensors and batteries and actuators. Musk said the machine will be limited to a walking speed of 8 kilometers per hour and will be deliberately weak enough that most humans will be able to overpower it if needed. You never know, said Musk, who had suggested earlier in his presentation that artificial general intelligence, hypothetical AIs that could complete any task a human can perform, was the largest threat currently facing humanity.
So Dojo is real. The Tesla bot will be real. Neural nets recognizing the world, understanding how to navigate through the world. It kind of makes sense to put that onto a humanoid form. We think we'll probably have a prototype sometime next year.
VR system that moves your body. There's nothing better than virtual reality for total immersion, but it's still lacking a tactile element that would really help the technology level up. According to a recent paper, researchers at the University of Chicago have developed a virtual and augmented reality system which moves the user's body for them, at least some of the time. Pads positioned on the neck muscles use electrical muscle stimulation to take control of a player's body and move it. In a fire safety demonstration, the technology was used to guide a player's eye line toward the location of a fire extinguisher or live fire. Additional demonstrations moved a player's head in response to a punch from a virtual boxing opponent. Importantly, the system senses what the user is doing in real time and only initiates an involuntary movement when the muscles aren't otherwise activated. So, there's no risk of injury as a result of a triggered motion, even if you're being punched in VR. Researchers believe this could change the way VR and AR experiences are developed by removing the need to add visual cues guiding a player. Biomni 1.0 Humanoid Robot. Biomni 1.0, it's the world's most sophisticated humanoid robot operated by humans who are assisted by an AI brain. This robot is designed for commercial use with a platform that will transition from a human pilot to full autonomy. It's a general-purpose robotic system that allows for remote work at a high level of fidelity to be done around the globe. It's the future of work where we can easily work globally without having to commute. Biomni makes it possible for us to reinvent world's workforce where, in the future, we can have a healthy, productive, and happy life. Biomni 1.0 Humanoid Robot by Beyond Imagination, or BE, aims to create a world where distance is no longer an obstacle. It allows remote work from wherever you are. The design features human-like waist, head, shoulders, hands, and arms with opposable thumbs. The operator can operate Biomni to perform fine tasks from pinching salt or lifting up to 35 pounds of weight per arm. However, it's more than just an avatar. It is hoped that Biomni evolves into a fully autonomous operation robot. The rechargeable battery allows this robot to operate for about 4 hours. Jumping robot reaches new heights. UC Santa Barbara engineers and Disney researchers have created a robotic device that can leap 32.9 meters into the air. That's 3 times higher than the current record for a jumping robot. In a recent paper published in scientific journal Nature, the team explains that their breakthrough was reached by investigating the differences between biological and mechanical jumpers. For centuries, scientists have explored the limits of biological jump height, and for decades, engineers have designed jumping machines that often mimicked or took inspiration from biological jumpers. Despite these efforts, general analyses are missing that compare the energetics of biological and engineered jumpers across scale, reads the paper. The researchers identified that a jumping animal, such as the tree frog that can bounce up to 10 times its own height, are limited by the power its muscles can produce in a single stroke. On the other hand, non-biological engineered devices can multiply this power with mechanisms like ratcheting or rotating to build up stored energy before being released. Using these insights, the UC Santa Barbara and Disney team designed the record-breaking jumping device with a base made of 2 intersecting carbon fiber legs that bend like the bow of an arrow. Rubber bands are connected from the carbon fiber legs to the center of the robot by a central line made of polyethylene. The device is compressed by a small motor that reels the polyethylene line. Once released by a lightweight unlatching mechanism, the robot transforms into an aerodynamic shape, and the stored energy of the compressed legs allow it to soar over 30 meters into the sky. Our work advances the understanding of jumping, shows a new level of performance, and underscores the importance of considering the differences between engineered and biological systems, adds the team. And what are the applications of a robot that can jump as high as a 10-story building? Well, the team says the design could be used for transportation on the Moon, where there's no atmosphere for flight. They estimate that on the surface of the Moon, their jumping robot could reach 125 meters high. Snake-like robot could explore Saturn. A snake-like robot made of giant screws and flexible joints that can travel across hard or loose surfaces and worm into tiny spaces, such as tubes and tunnels, may be key to exploring the interior of Saturn's icy moon Enceladus. While wheels or legs can traverse flat ground more efficiently, snake-like robots have several advantages. They can conform to tight bends, and their small cross-section allows them to fit through narrow spaces that would block other robot designs. Researchers in the National Aeronautics and Space Administration, or NASA, Jet Propulsion Laboratory, and the University of California, San Diego have developed a snake-like robot that could facilitate such exploration of the interior of Saturn's icy moon Enceladus. The Arc Snake, parts of which were inspired by previous work on a device for colonoscopies, features flexible joints and uses Archimedes screws to propel itself, can move across hard or loose surfaces and into tiny spaces. The Arc Snake is operated by a human controller by remotely manipulating a scale model of the robot. UC San Diego's Florian Richter said NASA wants to use the device on Enceladus to go down the plume vents and go through these ice caves and collect samples, and will feed data back to Earth and see what they find. Robots that sort out their own issues. Robots can help do a lot of things: assemble cars, search for explosives, cook a meal, or aid in surgery. But one thing they can't do is tell you how they're doing. Yet. UMass Lowell researchers are aiming to change that, working to give humanoid robots and other autonomous systems the ability to evaluate how well they can perform tasks or why they can't complete jobs. This assessment in real time is vital as robots become increasingly independent and are tasked with performing in remote, hostile, or unpredictable environments with minimal human supervision or intervention. Right now, robots can't gauge how well they are able to perform tasks, how a job is progressing, or tell you what their limitations or capabilities are. Our goal is to develop methods and metrics that would enable autonomous systems to assess their own performance, said UMass Lowell computer science professor Holly Yanko, a renowned robotics expert who established the university's robotics lab and the New England Robotics Validation and Experimentation Center at UMass Lowell, one of the country's most advanced robotics testing facilities. That's all for this video, folks. See you another time.